And now I would like to invite Tiberiu Lepadatu to share his screen and tell us a bit more about your project about HPC performance profiling tool. The floor is yours. Thank you.
Hello, my name is Tiberiu Lepadatu, and today I'm going to talk to you about the high performance computing performance profiling tool that I've developed in the last few months with the help from my mentors, Olivier, Michael, and Clark. Firstly, why do we want to create a profiling tool? Of course, there are many profiling tools in the IFS that people use. But as Ayush has already told you, IFS is a very big and complex project which has thousands of routines and subcomponents, and they are very different in the view of performance characteristics. So to understand these performance models, these characteristics that HPC in a very complex system, it's very complex for an engineer. So even though there are a variety of built-in performance measurements, we need to aggregate them, and I'm going to show you in the next few slides some raw data, and you are going to understand why the raw data are not good enough, and this project is really important. The aim of our project is to make a way of presenting the data in an interface which presents the data in a way that people can understand, can comprehend very easily. Also to use try to have a comparison oriented view in respect of the data, and also to understand which impact small change in the code has on the IFS code base. Also, we really want to have all the data available everywhere. So by having a dashboard, a web-based dashboard, we can access it from any device. And it's very important to me and also to my mentors that the interface is very flexible and extendable. So this is the wall of text that the HPC profiling tools give out. You can see here that is the total number of seconds that we have for a routine, here the total number of calls, but it's very hard to understand which are the main outliers or which are the outliers of the run, and how your changes to the code has impacted the performance of the IFS. So we are proposing something much easier to understand, interactable and graphical interface that you can see here directly the relationship between these two routines. As value here, we have the total time that you can see in here, and everything is very simple, and you can see just by one view every data that you want. So basically we are transitioning, we are trying to make this into this and into many graphs. What have we done so far? We've analyzed many benchmarks tools. For example, we've analyzed Scalaska or iPerf and many others. And we've looked there to see which are the most important ways of visualizing data. Then we've created some initial plots in the Jupyter Notebook that I'm going to show to you in the next slide. And then we've started playing with the layouts of the dashboard. And in the end, we've implemented a server that it's acting as a proxy between what we have done in the Jupyter Notebook and what we have on the dashboard. So we are practically just calling out all the methods from Python, from the Jupyter Notebook, into a very beautiful interface. We had a lot of challenges along the way. First of all of the plotting libraries have a different way of saving the output. Some of them use HTML, some of them use SVG, some of them use JPEGs, and so on. So it's very hard to make a tool that's a hammer that can strike them all, let's say. Then it's very hard to call Python functions from JavaScript. So we've abandoned this idea. We have made something, an artificial way of calling Python functions. Also, Plotly has a very weird way of saving HTMLs, and one of the biggest problems was that the final output of the project should be configurable from Python. And Python has a very, let's say, rough around the edges way of creating interfaces. For those of you who have played with it, you know what I'm talking about. So this is what I've done in Jupyter Notebook. This is the custom spider graph. Why is it custom? Because you see here the DPOps, or the floating point operation executed optimized to count, scale, double precision vector operations, goes from 6,100 and something to 9,099. So very big numbers, but the time goes from 6 to 9, so single digit number. So we've done something to be able to see all of them on the same graph. So it's this graph doesn't come from any library, it's done by us. It's something really special to this project. It's kind of awesome in my opinion. So yeah, so we took this graph, this awesome graph that we've created, and we just call it from the React interface. So everything just goes from here into here in some simple steps. You just have to configure a JSON file, and that's all. So this is the flexibility that I've talked to you about in the first slide. What we want to do in the future, we firstly want to stabilize the server and the front end. We want to take your advice on the front end, your tips on how the front end should look like. On the part of stabilizing the server, we are talking about what can be calculated on the server and what should be calculated on the front end, because for us, interactability, the possibility to interact with the graph, it's a very high priority. Then we want to implement authentication on the server so that your configuration of the dashboard can be saved and you can come back to it, or maybe you can share it as well. Then we are going to create a Docker container for the application and let everybody test it out. And in the end, I want to make a guide of how to create new metrics and let you guys hack my application to make something new out of it. What's important, what are the takeaways, in my opinion, are that we want to make an application that it's very easy to use, extendable. It's language and framework agnostic, because we don't want to care if you are going to use matplotlib or plotly or anything else to generate the plots. And also, we want to make a very easy tool to make sense of the data, the performance data that the IFS gives out. Thank you very much for your attention, and I'm waiting for your questions.
Thank you, Tiberiu. We actually have one question on Slido, which we can address now. Is your profiling tool or framework adaptable to other projects other than the IFS? How intrusive or easy to profile a separate project is it?
Well, what I'm doing right now is creating an interface in React, and you are just calling from there. You are calling some server functions through a REST API. Actually, I have a photo if I can show it to you very fast. So wait a second. Share screen, desktop. do, I think. Okay, share. 1 second. I'm going to show a picture of the architecture that I have on the right now, so it will be very easy to understand. Okay, so this is the architecture that I'm using. I have here a Python server and a Python proxy. So if you want to implement the performance tool in your application, you are just going to write the server because the client is already written. So you are going to write there what performance tool you want, what performance metrics you want, and how do you want your graphs to behave. So it's pretty simple, pretty adaptable in my opinion.
Okay, perfect. Thank you to Bergu.